Okay, I think we've hit this a great deal, but I just want to make sure we're all clear on some of the roles of water and the qualities we're dealing with here. Just to remember that oxygen and hydrogen have a large enough difference in their electronegativity to allow this to have a small negative charge, this a small positive charge, or partial negative and partial positive, hence that the lowercase delta here, all right? Giving you one side of the molecule being positive, the other side being negative. Which means there's a consequence to everything. That's the problem with the universe. It's not any one thing, then you're done. No, every one thing impacts every other thing, right? So when you're dealing with water, having a negative and a positive, that gives water an ability when you put, like, for instance, salt, NaCl, which is ionic. And remembering back on what the difference between ionic and covalent bonding, ionic means that this one took or gave up its electron, is positively charged. This one took the electrons, negatively charged. Then water, the negative end of the water is going to surround the sodium, and the positive end of the water is going to surround the chlorine. And as such, what happens is that you get sodium chloride dissolving in water. That's what dissolving means, is that it's hydrated or surrounded by water, or in this case water, but by a solvent. Because water is polar, because it has these dipoles, right? Because there's a separation of charge in the molecule, and it's small, and it can form these hydrogen bonds with itself, it's able to surround things and dissolve things incredibly well, especially if they're polar substances. And so what you get is you get the ability of water to dissolve numerous ions. So salt water is just chock full of minerals that are dissolved in it. So poo and pee and just about anything gets dissolved in water, which is why we use water as a solvent even in our own homes when we're cleaning the floor or washing the dishes. So when we're talking about water, water has this ability to dissolve things, which is why we say it's called the universal solvent. It can dissolve so many things, probably more than anything, just about anything else, especially if it's polar, if they're polar or ionic. Remember, ionic means they have charges, and polar means they have positive charges, and the charges attract, like you see here with the sodium and the chloride. So the other thing is that water is able to hold on to its energy, right? So water's able to take in a lot of energy. If you have a gram of water, right? A cube of water. Let's just say a cube of water. Water is going to be able to take in a lot of energy here before it increases in temperature. And the temperature, remember, is the average kinetic energy. So in order to get water to move, to increase its kinetic energy, you have to put a lot of heat into it. So that means when you sweat, when that water goes from, the surface of your skin and evaporates into the air, it's taking a lot of heat with it. It's thermally stable. So it takes a lot to move, to change its temperature, which is a good thing. Whether you're a shark, the way it is in this picture, or you're a human being, you want to not have to worry about the temperature outside changing the internal temperature of your body. It takes a lot to change that temperature of your body. And it also allows you to cool off quickly, because as that water changes state, it takes with it a lot of heat energy, because it can hold so much energy. When we look at water's colorless, and it lets a lot of light through. That's essential if you're a plant underwater. it's essential that light can penetrate all the way down. Even though in the ocean, you have a lot of salt dissolved in that water, that salt water is still clear enough to allow light through. Imagine if that salt water was murky, was dark, and didn't let sun through. There wouldn't be any plant life in the ocean. And the fact that the solid form of water is less dense than the liquid form allows ice to float, which allows life on Earth to exist. And the fact that part of that, all of these, for a lot of the reasons here is the hydrogen bonding that's going on between the water molecules, by the way. Remember, it's the pulling of one molecule to the other that makes it so difficult to change water's temperature, to makes it so difficult for water to change to gas, that makes it so plausible that something could walk on water, because water can hold the surface tension, or what the molecules themselves hold each other together. And the fact that their shape, when it turns into a solid, their hydrogen bonding requires that they form a specific shape, geometric shape, that's less dense than the liquid form, making it float. All these things are, and most of the qualities of water have to do with the hydrogen bonding that happens in between the water molecules. So these are all very important parts of water and how water works for life.